Hi, people. So, today we're going to do one of the first parts of the lessons in partial fractions. Okay, basically, what a partial fraction is we're going to take a rational expression, which is pretty much a fraction, and we're going to break them up into either a sum of two or more simpler rational expressions. So, we're looking to factor some of these, and by doing so with these partial fractions, we make it able to integrate. Okay. The partial fractions is stuff that's covered in pre-calculus, and in calculus, we are going to integrate it. Okay. So I know some of you guys haven't done it before. If you had me for honors pre-calc, this is basically a review, and I do know that sometimes things get forgotten. So, anyways, we'll start off with a rational expression. Okay, we'll start off with x plus 7 all over x squared minus x minus 6. Okay, something like this we would not be able to integrate as is. You couldn't do u substitution or anything like that. So what we're going to do is we're going to do the decomposition of it so that we can make it possible to integrate. Okay, so there are actually several different types of partial fractions, and it's all going to be uh, figured out by when you factor the denominator, if they are repeating itself, if it's a quadratic, or are they are independent of each other. We'll get a little bit more into this. This one right here is actually going to be a distinct linear factor, and we'll talk about why it is in just a second. So this one right here is a distinct linear factor. Okay, so we've got to break this up into a sum of two or more simpler rational expressions. So up top, we'll keep it the same, x plus 7. In the denominator, we are going to factor x squared minus x minus 6. Okay. So factoring out, we've got x here, plus minus. So we'll have plus 2 minus 3. Okay. So if you notice, these two have pretty much no relationship with each other. So that's why this is called a distinct linear factor. If we had x plus 2 and x plus 2 again, that's what we call repeating. But right now and for today, we're just going to do distinct linear factor. So we've got to break this up into a sum. Okay. So how we break this up into sum, we're going to write it like this. Okay. Let me get rid of this bottom. Okay. Oops. Wrong color. Okay. We are going to take the first factor. Okay. Doesn't matter which one's first, x plus 2 or x minus 3. It doesn't really matter which one it is. So if we put x plus 2 here, I'm going to put an a up top. And then we're going to add, because we're looking for the sum of it, we're going to put the other factor here, x minus 3, and we're going to put a b up here. Okay, again, we're only doing distinct linear factors right now. We're not trying to overload you on everything else. Okay, so the next thing we're trying to do is we're going to get rid of this denominator. Okay, and we're just going to have x plus 7 here on the left. On the right, we've got a over x plus 2 and b over x minus 3. Whenever we want to add two fractions together, we must have the common denominator. Okay? In this case, our common denominator is going to equal x plus 2 x minus 3, which of course is the same thing as this. Okay? But we don't really want this denominator anymore. Okay? But so what we're going to have here is we're going to have a. Okay? And if our common denominator, actually, let me rewrite it with our denominators. So you can see this next step. Okay. So here with a, when we're trying to add these two against our common denominator, we had to multiply x minus 3. So since we had to multiply x minus 3 in the denominator, we've got to do it in the numerator. Likewise over here, we're going to multiply this by x plus 2. Okay, so notice it says x plus 7 over quantity x plus 2 times quantity x minus 3, is equal to what we have on the left. Okay, so we're not going to even worry about our denominator anymore. So what we're going to have is x plus 7 equals a times the quantity x minus 3 plus b times x plus 2. Okay? Now, looking back up here, this is the form that we are going to want our partial fraction to end up as, not this down here. Not this down here. We don't want it to end up with the denominators like that. Okay. So the next thing we're trying to solve for is our a and our b, because they are going to plug into here. Okay. So for here, one way to do this, and I think is the easiest way to do it, is to eliminate one of the, either the a or the b. Okay. So one way we can eliminate it, we'll start out with eliminating b. Start eliminating b. And one way to do this is we will set x equal to -2. Okay. So when we plug it in, our x in, we will get -2 plus 7 equals a minus 2 minus 3 plus b times -2 plus 2. Okay, and this is how we are eliminating b. So on this left side, we get 5 equals a minus 5 plus b times 0 which will equal 0. So we're left with 5 equals negative 5a. And therefore, a is equal to 5 over negative 5, which will then equal negative 1. Okay. What we're going to do with this negative 1 is we're going to substitute it back in for a. Okay, because our end goal is to get this right here, that a over x plus 1 plus b over the quantity x minus 1. So now we have to find our b. Okay, so in order to do that, we're going to eliminate a. So therefore, we're going to select or let x equal 3, because we're going to eliminate 3 right there. So we'll let x equal 3. Okay, using this right here, we'll have 3 plus 7 equals a. 3 minus 3 plus b times 3 plus 2. Okay. So on the left, we get 10 equals a times 0 plus 5b. Okay, so 10 equals 5b. B is equal to 2. Okay, so once again, we're going to take this 2, then we're going to plug it into there. So to finish it off, we get a equals negative 1. So we have negative 1 over x plus 2 plus b equals 2. We've got 2 over x minus 3. Okay. We could rewrite this. We're left with 2 over x minus 3 minus 1 all over x plus 2. Okay, and that is our partial fraction. Okay, and that is something that we would be able to integrate. Okay, so post this on the website Schoology. Okay, I'll talk to you tomorrow. Don't forget to hit the like button and subscribe to my channel. Okay, Mr. Yoso, talk to you soon. Bye.